to Biostatistics. Today we want to start dealing with Biostatistics. And as always, please feel free to ask questions, feel free to participate, and let us interact together. So we are looking at the introduction to Biostatistics. So don't fear Biostatistics. It's one of the interesting course. I will not say simple, but it's one of the interesting course. And if you master the concept behind it, it becomes even more interesting. Yeah, so over the past 2 weeks, we have been looking at epidemiology, where we are looking at the cause and distribution of diseases in a population. Okay, so now to understand more on the problem in the population, we can use biostatistics, okay, to understand more on what is happening in the population, who is affected, is there a relationship, okay, is there an association, is there a link between this factor and the outcome, okay, or this factor and the disease? Is there a link between them? So biostatistics is a powerful tool that can help us to understand the relationships between the cause and the effect. Okay, so today we just try to focus on defining biostatistics and to discuss the importance of biostatistics. Why should we study biostatistics? Then we look at the types of variables, which are the characteristics that were being measured on the subject in the study or the patients in the study. What characteristics are we interested in? What are we interested to measure in these patients? Okay, so that's what we are going to discuss today. Okay, so first, what is biostatistics? Anyone who can try to help us define what biostatistics is? What is biostatistics? Anyone who can try to help us? Anyone who can try to help us? Okay, so to easily understand the term, we can use we have to break it first. Okay, first we need to break the term biostatistics. So we have the term biostatistics here. Okay, and when you look at this word, it can be divided into two parts. We have the bio, okay, we have the bio and the statistics. Okay, so what is bio first? Okay, bio means the study. Study of what?
Study of numbers.
Okay, so bio is from the very familiar word, which is biology. Okay, so bio represent living organisms, represent life. Okay, when you hear about bio, it represent life, it represent living organisms. Okay, then we have statistics again, which refer to the numbers like you have put it. Okay, so a statistics itself, if we break it, it's a science. Okay, a statistics itself is a science that deals with the correcting. Okay, correcting, um, organizing, analyzing, interpretation, and presentation of numeric information. Okay, which is numbers, correcting of numbers, and organizing. Okay, so here is a patient who comes to the hospital. You have a patient who comes to the hospital who is sick. Okay, this is your patient. So when this patient comes to the hospital, we need to get some information, okay, from this patient. Okay, we need to get their names first. Okay, who are you? We need to get their gender. Okay, we need to get uh, those vitals that we take. We need to get the temperature. Okay, we need to get what else do we get from the patient?
The weight, the height.
You need to get the weight, you get the height, and what? And BP, blood pressure. Okay, we need to get this information. All right. Let me try to admit some people. Oh yeah. So we need to correct this information from the patient. We need to get their names. We need to get their gender. We need to get the temperature. We need to get the weight, the height, and the BP. So this information, when we analyze, when we get this information and organize it the way I have organized it like this, okay, it will be easy for someone to read, to understand this patient. And after you read and understand this patient, you analyze this patient. Okay, you take these vitals to understand the state in which the patient is. Okay, um, you want to check the temperature if it's in the normal range. What is the normal range for temperature?
36.5 to 37.5.
Yes, 36.5 to 37.5. And you analyze this. You take this temperature from the patient so that you can analyze if it is falls in that range, in the normal range. You also get the weight because you want to understand, is this weight age appropriate? Okay, you find the person who is uh, 25 years old and is wearing 150. That is too much. Okay, a person who is 25 and is wearing 30, that is too small again. So you want to understand, is this uh, age appropriate? Okay, are they malnourished, or maybe they're obese or overweight? You want to check the height so that it can help you calculate um, the body mass index. Okay, you are getting the BP, because there is a normal BP that we expect a patient to have. So now that is interpretation, analyzation, and interpretation. So your if your temperature that you get from a patient is let me say is 49, okay, what is your interpretation of this temperature? What can be your interpretation? How do you understand these results?
Your question again, sir.
I mean, if you get you you measure temperature for a patient and you find it to be 49, what is your interpretation?
It's very high, sir.
It's very high, right?
Mm.
Yeah, it's above the normal. So this patient is likely to be very sick. Okay, so we need to admit this patient. And when you look at, so now after you have interpreted these findings, where do you go? You go to your doctor and present what you have found, right? You do the presentation. So statistics involves the correction of this information. Okay, so whether you are doing a study, the first step that you do is to correct the information. After you correct the information, you have to organize it. Okay, put it in proper arrangement. Okay, so organization just simply means putting this information now in a very well arranged manner. Okay, that can help people to understand it. You group it. After you have grouped it, you need to analyze it. Okay, analyze it, understand what does this information means. Okay, then interpret and present your findings. Okay, so when you are doing about statistics, normally we are correcting numeric what, numeric information. Okay, so when you are correcting this information, when it comes to gender, gender can seem not to be a numeric information, but we want to know how many male and how many female came to this facility. Remember, when we are looking at the odd ratio and the risk ratio, you find that the risk ratio in male and female differs based on how many female are affected and how many male are affected. So it still become important numeric variable that we can use in a study. So this is a statistics. Okay. Again, is to say that a statistics is an estimate of an known numeric quantities. So when we are doing a study, okay, when we are doing a study or a research, do we have to do a research in the entire population?
No.
No, we don't do a study in the entire population. So what we do, we use a sample. Okay, we use a sample which is a subset of the entire population. So after we use this sample, the result that we found, we use those results to make a conclusion for the entire population. We make uh, we use this the result from the sample we use to estimate the parameters of the entire population. So if we are looking at maybe a condition and you find that from your sample, okay, from your sample you find that more female are affected, okay, you find that more females are affected than males. You use this same result to make an estimate that in the entire population, Females are more affected than males, but you did not get this information from the entire population. You only got this information from a sample. So a sample, it will help you to estimate the entire population, what is happening in the entire what, in the entire population. Are we together? Yeah. So the information that you get from um, the sample is a statistic which you use to estimate the parameters. Parameter is the information that you are getting from the population. Okay. So, biostatistics is the science of statistics applied to the biological sciences. So, I'm sure we are all familiar with the biology. Okay. So, now statistics is the science of statistics, this science of correcting, organizing, analyzing, interpreting, and the presentation of information now done in biological sciences. So when we are dealing about, when we are talking about biological sciences, we are talking about health sciences, okay, which involves living organism. It can be in animal science, it can be in plant science, it can be in human science. So as long as we're dealing with the living organisms. Okay, so that is biostatistics. Any questions so far? Okay, yeah. So fundamental statistics method do not change across discipline. So when you are looking at these statistics, either you learn it in agriculture, you learn it mining, or anywhere, the fundamental, the method that we use, they do not change. But what change is application and the different problems that we are solving in different disciplines. So the same method that we are using everywhere is the same method that we are going to use. So now, what is the importance of biostatistics? Why should we suffer to learn biostatistics? Okay, so biostatistics will help us to make good clinical decisions. Okay, it helps us to make good clinical decisions, which will enable us to distinguish between discrepant data and the routine variability. Okay, it will help us to understand discrepant data and routine variability. So just like we were discussing yesterday about the outbreak, okay, so the routine variability, it talks about the data that is expected, the outcome which is expected. So at each health facility, when it comes to diseases, there is an expected number for each condition according to the normal, the way it is every time. Okay, so every time there is a curve of how the disease is in the population. Maybe for malaria, you find that you have a curve, maybe which is like this, depending on the month. Sometimes it goes up, sometimes it comes down. So there is that range. Okay. Now, if there is discrepancy in this data, you find that sometimes um, the data goes up, okay, and comes down, yeah, just like that. It goes up and comes down. So now biostatistics help us to rule, is this just by error, okay, or maybe this data that we have seen, there is something significant that has happened in the community, or is by error, because sometimes there can be error in how this data is reported on the reporting. Okay, people can make errors. So biostatistics help us to rule out, is there just an error, or there's something that has happened, or which makes these results to be different from our routine variability, our routine expectation, because for each health condition you are going to have unexpected cases each month. Okay, so biostatistics will also help us to understand and evaluate medical literature in an intelligent manner. Have we done a research method? Did we do research method?
Yes.
Okay, great. So when you are doing research method, there is a part for literature review. Okay, there is a part for literature review, and when you are doing literature review, you find uh, one or two interesting parts. Number one, you need to look at what method was used to correct this data. Okay, what method was used to correct this data? We look at the study design. What study design was used? How many study design did you run? Or what are some of the study design that are used to correct data? Hello? What are some of the study design that are used to in research? Madam Lydia?
So there are two study design.
Okay.
That's quantitative and qualitative.
You have quantitative, okay, and qualitative study design. Okay. So after now you have known the study design, also you need to know the data analysis method. I'm sure you have done data analysis, right? Yeah, so each data, it has a way that needs to be analyzed. The categorical data, or sorry, the qualitative data and the quantitative data, there is a way that this data is supposed to be analyzed. Okay, and one of the method is thematic analysis for qualitative data, where you need to identify the themes that are coming um, from the data. So themes simply means uh, the the main point, the major point that people are raising as you are interviewing them. What are the things that they are saying? So that is uh, qualitative data used, or thematic analysis used to analyze qualitative data. Then when you go to quantitative data, there are other methods that are used to analyze the data, like descriptive analysis and inferential statistics, which try to now to understand the relationship between variables. Okay, what is the relationship between two variables? You can look at maybe um, we have malaria. Okay, if we have malaria and um, we have gender. Okay, we have gender, we have male and female. You want to look at, is there a relationship, okay, between male and between gender and malaria? Okay, who is the most affected? Okay, so you want to look at the relationship in terms of gender and malaria. Who is the most affected? So you find that the characteristics of these people influence um, their vulnerability to malaria. Okay, so you need to look at this. So now, inferential statistics like chi-square, we have learned about chi-square, or we are going to learn about chi-square. They will help you to determine if there is a relationship between these two variables. Okay, or maybe you want to look at the relationship between maybe heart disease and income level. Okay, you want to find, is there a relationship, is there an association, are these things related? Okay, so you look at the different levels of income and the heart failure, is there an association between these two variables? So biostatistics, it is going to help you to interpret, okay, the medical or literature, okay, in an intelligent manner, because it will allow you now to understand where there is a relationship and where there is no relationship. Okay, and it will help you now to do the conclusion based on the design of the study. Okay, the design of the study, did you use qualitative, did you use quantitative, and also the analysis that was performed, did we do a thematic analysis, did we do descriptive analysis, or did we perform inferential statistics here, where we were determining the relationship using different statistical methods? Okay, are we together? So each article that you are reading, okay, each article that you are reading, you have to look at what study design was used here. After you understand the study design, what uh, type of analysis was performed? What analysis method was used to analyze the data? Okay. After that, you can make a conclusion. So, when you read literature, please check for this. If you find time today to read an article, check for the study design that was used and also the data analysis method which was used to analyze the data. Okay. Any questions so far? Are we together? So, biostatistics also help you to change the way you do things, the way you work. Okay? It will help you to rely on literature for new information. Because trust me, maybe during the time when you are being trained as nurses, okay, there are a lot of things that have changed up to this level. The way you used to treat TB is not the same. There are new medications, there are new indications that have come for TB, okay? And if you don't read, you cannot understand, you cannot improve. So, for everyone to improve in the medical profession, you need to read, you need to rely on new information. Me, I've even seen some doctors when they are screening you, they're asking you questions, they even start Googling, okay? Because they want to understand. These things, they keep on changing. What you learned in class, you find is not what is on the ground. Okay, and you need to review literature, you need to understand, you need to read. So biostatistics, it will help you now to understand the literature very well and help you to improve your um, your understanding of things. Okay, so biostatistics also help you to understand the principles underlying the computation performed by computer. So when you are doing data analysis or when you are doing your research, mostly you are going to use computer. You are going to need computer. you are going to need some software like SPSS, where you are going to put your data and find out, okay, and do some computation in short. So uh, SPSS is more like a calculator where you enter your variables, your number, and you do some calculations to find out whatever you are interested to find out. So biostatistics is going to help you understand the outcome, okay, from the computer. Mm. Yeah. So, but statistics also going to help you to have an appreciation of biostatistics. You are going to know when and for what purpose a biostatistician should be consulted in medical research. So, especially for those who want to uh, do their research very well, maybe who are interested in doing research, maybe you are interested to apply for grants, they always require that you form a team, okay, you form a team who is going to analyze this data, because they know that you maybe as a nurse you might not be able to analyze and understand the data very well. You need a biostatistician who comes and do the analysis. So they will need different people who understand that field, okay. So always you have to work as a team. When you are doing a research, you have different people. So if you are doing a research that involves maybe um, environmental related issues, you need to get an environmental professional who understand how disease, uh, how the environment contribute to the cause of disease. So you need different people. You need to work with different people. So now, when you have learned about statistics, you'll be able to understand what time or why should I uh, bring in a biostatistician in my research. Okay, so most of you, after you have collected your data, you need to call someone to help you analyze, or maybe your supervisor will need to help you analyze this data. Okay, so that is the purpose of doing biostatistics. So these are just some literature. So now we go to the variables. Okay, variables. So a variable is a characteristics or numbers, okay, or trait measured on a study subject. So when we are looking at variables, I'm sure you did variables in research method. Variables, okay. So variables, when you, like I was saying, when someone comes to the health facility, or when you are doing a research, okay, when you are doing a research, you get information from people, or you measure some values from the people that are involved. So we got a patient here. This is a patient that we have, and we want to get information from this patient. So we are going to get different information. We are going to get age, okay. For instance, we can get age from this person. So now age becomes a what? A variable. Okay? We are going to get height, which is a variable. We're going to get temperature. We're going to get BP. So these are variables. Okay? These are variables. So a variable is a characteristics. Okay? Numbers or traits that are being measured on the study subject. Like this patient, we want to study their age. So when everyone, when they are coming, we are getting their age. Okay, we are getting their height, we are getting their temperature, we are getting the BP. So this variable may vary from one person to another. They won't be the same for each person. So we have different age, we have different heights, we have different temperature, and we have different BP for each patient. So a variable is just a characteristics that we are measuring from our patient. Okay. Any question? Any other example of variables? Let's list some variables here. Examples.
Dependent and independent variables.
Okay. So now those are the
Gender.
types of variables. We'll learn more about them. Those are the types of variables. Those comes when you are comparing variables. You want to know which variable affect which. Okay. For instance,
So another example of variable. Oh,
the,
sorry.
for instance,
Another example of variable is
okay, you can go
pressure.
ahead.
I'm saying another example of variables is blood pressure.
Yes, we have included it here.
You have gender, marital status.
Yeah, gender. Yes, we have gender. We have marital status. What other variable? What are the example variables?
Weight, blood type.
Weight, blood group.
Presence of disease.
Yes, presence of disease. Okay, which can be status, either positive or negative sometimes. Okay, what are the variable?
Race.
Less. Okay, so these are all variables that we can measure from the patient. Okay, so when we talk about independent and dependent variables, now we are trying to understand the relationship, which one influence which one. For instance, we have BP and the age. Okay, there is a relationship between BP and age, right? Maybe age can influence what? Can influence BP. Okay, because you find that the older you grow, the higher risk of high blood pressure, right? Are we together?
Yes, sir.
Yeah. So now when it comes to these variables, they are in types. Okay, they are in types. There is what we call categorical variables. Okay, they are what we call categorical variables and numeric variables. So like we have been listing them. When it comes to gender, okay, gender is in two categories, right? We have male and what? And female. Okay, so because we can categorize this data, this variable into two groups, it becomes a what? A categorical variable. Okay, so all those variables that we can group, or they have groups, they have categories, they are called categorical variables. What are the example of categorical variables can we give? What are the example of categorical variables?
Marital status.
Marital
Blood type.
status. We have the married people and the single people. There are other like the divorced and the separated. Okay, these are
Blue color.
categories that you
We have
find.
black one.
Yes. What else?
The social status. The height as well.
Yeah, the social status. Okay, we have raw economic social status. Okay, we have high economic social status and middle economic social status. So we have different categories. So these are called categorical variables. On the other hand, we have numeric what? Variables. Okay, we have numeric variables. These are variables that are in numbers. Okay, so example, we have BP, okay, which can be in numbers. We have BP as what is those categories? First, we have systolic and diastolic, okay, which can be maybe, how do you write? Is it 120? Example, okay, like that. We have height, okay, which can be 1.5. What are the numeric variables do we have?
Temperature.
We have temperature, which can be given maybe 36.6. Okay. What are the numeric variable? What are the example?
Age.
Eh?
Age. Age.
We have age, which can be 20 years. What are the variable? Number of students. How many are we here? We are 31 today. Okay. So they are different. There are so many variables that we can give. Now, these variables each is further categorized into other groups. Okay. I can't see where my rubber is today. Okay, where is my rubber? I want to remove these. Maybe it's to do this. Okay. These variables can be further have other groups. Okay, I'm trying to look at my rubber. I don't see it. Okay, I wanted to remove these one. So these variables, we said, can be further grouped into other groups like categorical variables. So when it comes to categorical variables, we have nominal and ordinal variables. Okay, so this depends on whether we can arrange the categories in a certain order or we cannot arrange these categories in an order. Okay, so for instance, when it comes to academic qualifications, okay, when it comes to academic qualification can be grouped in order starting from the lowest to the highest qualification. Okay, from the lowest to the highest qualification that one can have. So this can start from a grade 12 certificate to a PhD level, depending on the qualification that the person have. We can group them in that order. But when it comes to gender, okay, gender, there is no order that you can group because we are all the same. We don't have any order. There is no one who is the lowest, there is no one who is inferior. We are all same. Male and female are equal. So there is no order. So those that have order, like the academic qualification, they are called ordinal variables. Okay? Then those without order, they are nominal variables. So we can give other example of ordinal and nominal variables. So let's give some examples. Ordinal variables. Give me some example.
Socioeconomic status.
Yeah, socio-economic status. We have the low socio-economic status, the mid socio-economic status, and the higher socio-economic status. What are the variables? What are the variable falls under ordinal? Hello?
Numbers. Level of pain. The level of pain.
The salary level. Yeah, so the salary level can also be uh, ordinal variables. Okay, depending on the people that we have. There are those who are getting low salaries and those who are getting high salaries. Okay, so that becomes also ordinal variables. What about nominal? We can also be giving example of nominal variables. What are the example of nominal variables? Those without any order.
Blood type.
Yes.
Race.
Blood type or blood group. So when you look at blood type, there is no order there. Okay? The person who is blood A, those blood group B, there is no order. It's just categories. What other categories do we have here? What are the variable?
Religion.
Religion.
Race.
Yes,
Race.
race, religion. Okay? And race. They are whites,
Okay.
they are us black people. There is no order here. Okay? You cannot put these people in any order. We are all the same. Okay? We are all the same. So these are the nominal variable. What are the variables? What are the variable falls under nominal?
Occupation.
Occupation. Okay? There was always a fight at school. Okay? People want to know who is the greatest, the medical doctor, the nurse, the public health specialist, environmental health technologist. People are fighting, but everyone is important. Okay, so everyone plays a role that the other person cannot play. Okay, so we are all there as important people in the profession. So occupation is also has also no order. Okay, everyone plays a certain role that no one can play. It's more like a bicycle. If you know there is a small element that is used in the bicycle, if that element is not there, the bicycle cannot move. There is an element that is found in the free wheel. that it's just a thin element, a spring actually, just a spring is the smallest. If that spring is not there, the bicycle cannot move. Okay, you cannot ride the bicycle, but it's very small, and people don't even know it. Most people don't know it. They just use a bicycle, and you are enjoying the bicycle. Okay, so that is occupation. So now these are groups for categorical variables. We have nominal and ordinal. So each information that you are going to collect, as long as it's categorical, it's going to fall these groups. Then we have the numeric information, numeric data, which is further categorized into discrete and continuous variables. Okay, so we have discrete and continuous variables. Let's do this. This side will put discrete, this side will put continuous. So this continuous variable is n variable that can be in decimal places. Okay, that can have a decimal. Okay, writing sometimes is difficult. Okay, just be writing shortcuts. Each variable, any variable that can be in decimal. For instance, if you take height, okay, height can be in decimal. A person can be 1.2. Okay, temperature can be in decimal. A person can have temperature of 37.1. Okay, so any information that is in decimal places is a continuous variable. Okay, then we have the discrete variable. This is the information that can never be expressed in decimal places. For instance, the number of patients who come to the hospital. Okay, this can only be a whole number. So you can have 37 people coming to the hospital at a particular day. Okay, what other uh, discrete variables can we give?
Gravidity.
Sorry?
We can also have parity, the number of children one has.
The number of children, yes. Number of children one have. So you can have maybe 5 children. You can never have 5.1. Okay? That is the gist. What are the variable?
Maybe number of houses.
Number of houses you visited. Okay? When you are doing what program is that one? Child Health Week.
Yes.
You are reporting to your supervisor the number of visited the number of houses you visited. Okay, they can always be a whole number. You can't visit 1.5 houses, it's impossible. Okay, so these variables that can be a whole number, they are called discrete variables, and normally these can be counted. Normally these are found by counting, but these on the other side are normally found by what? Measuring. You have to measure. Okay, what other variable are there under continuous? Continuous variable, other example of continuous variables?
Weight.
Weight, yes. It can be 32.3, for example. What other variable?
Distance.
Yeah, distance. You are doing morning routine, is it morning exercise? You can cover a distance of 5.1 kilometer. Okay, what other variable.
Length.
Sorry?
Length.
Length. Yes. Length, you can have 1.2 meters. Okay, so there are so many variables. So each information that you are going to correct is going to fall under this variable. The first, you have to define it. Is it a categorical variable or is it a numeric variable? So normally when we are talking about categorical variable, these are variables that are usually used in qualitative. Okay, these are normally qualitative variables. Then the numeric variable are normally quantitative variables. So these are the types of variables that we are going to have and we are going to be using in research. Any question? Any question on this one? Okay, if there is no question, this is where we end for today. Thank you very much for joining, and we'll meet tomorrow.